February 1944. Luftwaffe fighter base at Dortmund, Germany. Major Heinrich Ehrler stood in the operations room studying reconnaissance photographs spread across the briefing table, and something about the numbers wasn't making sense. American P-51 Mustangs had been encountered over Magdeburg the previous day, 230 miles inside German territory, engaging in sustained combat before escorting their bombers home to England. The mathematics were impossible. Ehrler had flown Messerschmitt Bf 109s since 1940, fought over Britain, survived the Eastern Front, and understood fighter range calculations as intimately as his own reflexes. A single-engine fighter simply could not fly from English airbases, penetrate that deep into the Reich, fight for 15 minutes, burning fuel at combat power, and return home. The fuel capacity didn't exist. The laws of physics didn't permit it. Yet, American fighters were doing exactly that, and the implications were forcing German defensive doctrine into a complete rethinking of what was possible. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Luftwaffe's intelligence assessments throughout 1943 had been built on assumptions that seemed unshakable. Fighter aircraft faced an immutable trade-off between range and performance. You could build a heavy twin-engine fighter with long range, like the Messerschmitt Bf 1-10, but it would be vulnerable to nimble single-engine interceptors. Or you could build a lightweight single-engine fighter optimized for climb rate and maneuverability, but it would be chained to its airfield by a fuel tank that ran dry after 90 minutes of flight. This wasn't a theory. This was aerodynamic reality confirmed by every fighter design from every nation. The Supermarine Spitfire, perhaps the finest interceptor in existence, carried 85 gallons of internal fuel and could operate roughly 90 miles from its base before reserves forced it home. The Messerschmitt Bf 109G carried 88 gallons internally with a similar radius. The Focke-Wulf 190 carried something close. Even with external drop tanks, these fighters might push their combat radius to perhaps 150 or 180 miles under ideal conditions. The American P-47 Thunderbolt, a massive single-engine fighter that had appeared over Europe in early 1943, carried 305 gallons of fuel internally. This gave it better range than earlier American fighters, perhaps 200 miles of combat radius, but nowhere near enough to escort bombers deep into Germany. Luftwaffe pilots had learned to wait, let the American escorts reach their fuel limits, watch them waggle their wings in frustration and turn for home, then attack the bombers without interference. This tactic had worked throughout 1943. B-17 flying fortress formations, attempting to strike industrial targets deep in Germany, had suffered catastrophic losses once their escorts departed. The October 14, 1943 raid on Schweinfurt lost 60 bombers out of 291 dispatched. That represented a loss rate above 20%, mathematically unsustainable for any sustained bombing campaign. The Americans would either have to accept such losses or stop flying deep penetration missions. German defensive planning assumed the latter would prove necessary. Then, in December 1943, the P-51 Mustang began arriving in numbers with American fighter groups based in England. Initial Luftwaffe intelligence reports on the Mustang were mixed. The aircraft had been in limited Royal Air Force service since 1942, primarily for low-altitude reconnaissance and ground attack missions. RAF pilots praised its speed and handling below 15,000 feet, but noted it became sluggish at higher altitudes, where most air combat occurred. The original Allison-powered Mustangs weren't considered front-line fighters for high-altitude bomber escort. They were specialized aircraft filling niche roles. German intelligence files classified the Mustang as capable but not particularly threatening to defensive operations. What German intelligence hadn't fully grasped was that the Mustang arriving in American hands in late 1943 was fundamentally different from the aircraft the RAF had been flying. North American aviation had re-engined the design, replacing the Allison V-1710 with the British Rolls-Royce Merlin 61, the same engine that powered Spitfires. More precisely, American P-51Bs and Cs were receiving Packard-built versions of the Merlin, manufactured under license in Detroit. This engine transformation changed everything about the Mustang's high-altitude performance. The Merlin featured a two-stage, two-speed supercharger that maintained power output above 25,000 feet where the Allison had gasped for air. The same elegant airframe that had seemed like a low-altitude sports car suddenly became a high-altitude thoroughbred, capable of matching or exceeding any German fighter's performance above 20,000 feet. But even more significant than the engine change was something German pilots couldn't see from their cockpits during brief combat encounters. The Mustang's internal fuel capacity. The P-51B carried 184 gallons in wing tanks, plus an 85-gallon fuselage tank directly behind the cockpit. Total internal fuel, 269 gallons. This was only slightly less than the P-47 Thunderbolt, but the Mustang's aerodynamically efficient laminar flow wing design meant it burned fuel more slowly at cruise settings, where a Thunderbolt might consume 90 gallons per hour at normal cruise power. The Mustang sipped approximately 70 gallons per hour. That difference translated directly into range. With internal fuel alone, a Mustang could remain airborne for nearly 4 hours at cruise settings, covering well over 1,000 miles in that time. Combat radius, accounting for climb-out, combat operations at high power settings, and reserves, worked out to roughly 450 miles. This was already substantially better than earlier American fighters, enough to escort bombers considerably deeper into German territory than P-47's could manage. German intelligence became aware of improved Mustang range in January 1944, when combat reports noted American fighters maintaining escort positions farther into Reich airspace than previous experience suggested possible. Luftwaffe fighter controllers began adjusting intercept tactics, positioning defensive formations deeper inside Germany to engage bombers after the escorts presumably turned back. Except the escorts weren't turning back. Mission after mission through January and into February, American fighters stayed with the bomber formations. Luftwaffe pilots found themselves engaging P-51's over targets they'd considered safely beyond enemy fighter range. The defensive calculations weren't working anymore. Staff meetings at Luftwaffe Fighter Command grew tense as operational reality contradicted intelligence assessments. How were American single-engine fighters achieving this range? Several theories circulated. Perhaps the Americans had developed more efficient engines that consumed less fuel. Perhaps they were accepting dangerous low fuel reserves, gambling that they could make it home. Perhaps combat reports were exaggerating the depth of fighter penetration. Each theory had problems. Engine efficiency couldn't improve that dramatically without fundamental redesign. Flying with inadequate reserves would result in numerous fighters running out of fuel, crash landing in Germany or occupied territory. Yet this wasn't happening in numbers that would support the theory. And combat reports came from multiple independent sources, pilots who had no reason to coordinate false narratives. The answer arrived at Luftwaffe testing facilities in early March 1944 in a form so simple it seemed almost insulting. A downed P-51 recovered near Brandenburg included, still attached to the wing hardpoints, 2 streamlined cylinders, painted silver, external fuel tanks. Drop tanks weren't new technology. Every Air Force used them. The Bf-109 could carry a 300-litre centerline drop tank. The Fu-190 regularly flew with external tanks for ferry flights. The concept was straightforward. Carry extra fuel externally, burn it first, then jettison the empty tanks before entering combat to restore the aircraft's performance. What made these American tanks noteworthy wasn't the concept, it was the capacity. German engineers at the Rechlin Aircraft Testing Center measured the recovered tanks carefully. Length, approximately 108 inches. Diameter at the widest point, roughly 22 inches. Internal volume calculations indicated each tank held approximately 108 U.S. gallons. 2 tanks provided 216 additional gallons of fuel. Add that to the Mustang's internal capacity of 269 gallons and total fuel load reached 485 gallons. At cruise consumption of 70 gallons per hour, flight endurance extended to nearly 7 hours. Combat radius, accounting for all operational factors, pushed past 750 miles. 750 miles meant a Mustang could fly from England to Berlin, fight over the German capital, and return home with fuel reserves. The numbers finally made sense, but the tanks themselves presented a puzzle that went beyond simple mathematics. One of the engineering staff at Rechlin ran his hand along the tank's surface and felt something unexpected. The silver paint coating the exterior couldn't disguise the texture underneath. This wasn't aluminum. It wasn't steel. When a technician carefully scraped away a small section of paint near the tail cone, the material beneath revealed itself. Layers of heavy paper, each perhaps 0.5 millimeter thick, compressed and laminated together with resinous adhesive. The Americans were manufacturing fuel tanks from paper. Materials specialists were brought in immediately. The construction proved sophisticated despite the seemingly crude material. The paper was identified as kraft paper, produced through chemical pulping processes that created exceptionally strong cellulose fibers. The adhesive was a phenylformaldehyde resin, a thermosetting polymer that created bonds stronger than the paper itself when heat-cured. The lamination process involved at least 12 separate layers, each oriented to provide strength in multiple directions. Anti-slosh baffles made from thin wood strips prevented fuel from surging during maneuvers. The fuel fittings were precisely machined brass, properly sealed. The interior was coated with a cellulose-based lacquer designed to resist aviation gasoline's corrosive properties. Every aspect of the design reflected systematic engineering for a specific purpose. Create a disposable fuel tank from non-strategic materials that could be manufactured quickly in massive quantities. The empty tank weighed approximately 80 pounds, not significantly lighter than a comparable metal tank. Weight wasn't the advantage. The advantage was production. Paper and wood-based resins didn't require aluminum, steel, or other metals increasingly scarce in wartime economies. The manufacturing process required no specialized metalworking equipment, no skilled metal workers, no welding or forming of sheet metal. These tanks could be produced in any paper mill or packaging plant, with relatively simple modifications to existing equipment. The United States had hundreds of such facilities. If even a small percentage of American paper production capacity had been converted to drop tank manufacturing, output could reach thousands of units per week. The tanks appeared to have no serial numbers, no manufacturer markings, nothing to indicate limited production. They were commodity items, mass-produced and completely expendable. Intelligence officers began researching American paper industry capacity. The data was sobering. The United States produced approximately 12 million tons of paper annually before the war, with production increasing during wartime mobilization. Converting even 1% of this capacity to drop tank production would yield over 100,000 tanks per month, far exceeding any plausible requirement for P-51 operations. The real constraint wouldn't be materials, but rather manufacturing equipment and labor to assemble the tanks. But this was precisely the type of manufacturing that could be performed by semi-skilled workers after minimal training. The paper tanks represented industrial efficiency and resource optimization on a scale that German planners found difficult to fully comprehend. Further analysis revealed additional design sophistication. The tanks were strictly single-use items. The phenolic adhesive, while creating strong bonds when cured, was slowly dissolved by prolonged contact with aviation gasoline. Intelligence reports and interrogation of captured American aircrew indicated that paper tanks had to be filled immediately before flight and couldn't be stored for more than a few hours without developing leaks. This wasn't a limitation affecting operational use. Fighters were fueled as part of pre-flight preparation. The tanks would be used for a few hours during the mission, then jettisoned. The single-use nature actually simplified logistics. No need to recover and reuse the tanks. No need for cleaning, inspection, or maintenance. They were expendable by design. German evaluation also noted the color coding. Paper drop tanks were painted silver, while metal tanks used by American forces were painted gray. This color distinction allowed ground crews to quickly identify tank types during fueling operations. The silver finish on paper tanks also helped reflect solar heat, reducing fuel evaporation and vapor pressure issues at altitude. Every aspect of the design reflected systematic engineering optimization for mass production and field use. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late March 1944, German intelligence had traced the origin of paper drop tanks to British development. The Air Ministry in London had commissioned development of impregnated paper fuel tanks in 1943 to conserve strategic metals, particularly aluminum. The Bowater Scott Corporation, utilizing expertise in paper manufacturing, developed the production process. The tanks entered service with RAF fighter squadrons in late 1943. American forces quickly adopted the design, with multiple manufacturers in both Britain and the United States producing tanks for use by USAAF fighter groups. The innovation had been driven by British resource scarcity, but was being exploited on massive scale by American industrial capacity. The broader implications extended far beyond fuel tanks. German technical staff began systematic review of captured American equipment, looking for other examples of industrial innovation and mass production techniques. The results painted a consistent picture. American equipment wasn't always technologically superior to German equivalents in terms of individual component performance. German optics were often better. German small arms were often more sophisticated in design. German armor metallurgy was in some respects more advanced. But American equipment was consistently better manufactured, more standardized, more reliable, and available in vastly greater quantities. The American approach prioritized producibility over perfection. Components were designed from the outset for mass production by semi-skilled workers using standardized tooling. Parts were interchangeable between units without hand-fitting. Assembly line methods reduced production time and increased output. The contrast with German production methods was stark. German weapons and equipment were often technical masterpieces, hand-fitted by skilled craftsmen. A German tank or aircraft engine represented the peak of precision engineering, but building such equipment required skilled labor, specialized tools, and significant time per unit. Production rates were constrained by availability of master craftsmen and precision manufacturing equipment. The Germans built superior individual items. The Americans built adequate items in overwhelming quantities. In industrial warfare, quantity had proven decisive. Analysis of P-51 Mustang production illustrated this principle. North American Aviation had designed the original Mustang prototype in response to a British requirement in 1940. The prototype NA-73X was completed just 117 days after contract signature, one of the fastest design-to-prototype cycles in aviation history. First flight occurred on October 26, 1940. By 1944, North American was producing P-51 variants at 2 facilities. The Inglewood plant in California averaged approximately 364 Mustangs per month during peak production periods. The Dallas plant contributed additional production. Combined output across both facilities reached an average of approximately 574 P-51s per month during 1944, with production accelerating throughout the year. Peak monthly production would reach 881 aircraft in January 1945. Each P-51 required approximately 15,000 individual parts manufactured by hundreds of subcontractors across the United States. The Packard-built Merlin engines were produced in Detroit at rates exceeding 300 units per month. Final assembly of a P-51D required approximately 22,000 man-hours of labor, but the production line system meant completed aircraft rolled out of factories at intervals of a few hours. At peak efficiency, a new Mustang was completed approximately every 2 hours. The scale and efficiency of this production system exceeded anything Germany had achieved. Messerschmitt and Focke-Wulf combined produced approximately 600 fighters per month in early 1944. Despite operating under emergency priority programs and utilizing forced labor, German aircraft production could not match American output. The resource implications were equally sobering. American aluminum production in 1944 reached approximately 1.25 million tons, equivalent to £2.5 billion annually. This represented a massive increase from pre-war production of approximately 164,000 tons in 1939. Germany's aluminum production, by contrast, peaked at approximately 250,000 tons per year and was declining due to bombing of production facilities and loss of bauxite sources. The Americans had approximately 10 times Germany's aluminum production capacity. The decision to manufacture drop tanks from paper rather than aluminum wasn't driven by metal scarcity. The United States had sufficient aluminum to produce every drop tank in metal if desired. Paper was chosen because it was cheaper, required less critical manufacturing equipment, freed aluminum for other uses, and could be produced more quickly with less skilled labor. This was optimization, not desperation. The psychological impact of these revelations spread through Luftwaffe technical and operational communities. The paper drop tank became a symbol of American industrial capability and the fundamental disparity in resources between combatants. Captured examples were displayed at technical briefings for Luftwaffe personnel. Pilots transitioning to fighter units were shown the tanks and asked to calculate implications for combat tactics. The message was clear. American fighters could now escort bombers anywhere in Germany. The previous defensive strategy of waiting for Allied fighters to reach fuel limits and turn back was obsolete. Luftwaffe fighters would have to engage the escorts to reach the bombers, and those engagements would cost aircraft and pilots at rates Germany could not sustain. March 4, 1944. The morning weather briefing at Debden Airfield in England confirmed what pilots of the 4th Fighter Group had suspected when they woke before dawn. Conditions were marginal: thick clouds over the channel, icing possible at altitude, visibility limited. But the mission was going forward regardless. 64 P-51 Mustangs would escort B-17 bombers to Berlin, the German capital, 560 miles one way. The mission briefing had been blunt about what this meant strategically. No Allied fighter had ever reached Berlin. If Mustangs could escort bombers there and bring them home, the Luftwaffe had nowhere left to hide. German fighters had been retreating deeper into Reich territory, operating from bases they considered safe from American escorts. Berlin represented the psychological and practical heart of German air defense. If you could fight over Berlin, you could fight anywhere. Lieutenant Colonel Don Blakesley led the formation. A combat veteran who'd flown Spitfires with the RAF before transferring to American squadrons, Blakesley understood what this mission meant. He'd spent the previous evening with his engineering officer going over fuel calculations one more time. Each Mustang would carry full internal fuel, 269 gallons. Each would also carry two 108-gallon paper drop tanks under the wings, total fuel, 485 gallons. At cruise settings of approximately 280 miles per hour, fuel consumption would run about 70 gallons per hour. Flight time to Berlin, roughly 2 hours. Combat time over target, 15 to 20 minutes at high power settings, burning perhaps 30 gallons. Return flight, another 2 hours. Total fuel required, approximately 340 gallons, leaving reserves of over 100 gallons for contingencies. The math worked, but only barely. There was no room for error, no fuel for extended combat or navigation mistakes. The Mustangs lifted off from Debden at 10:15 in the morning, wings heavy with drop tanks that added drag and reduced climb performance. The formation climbed through clouds, breaking into clear sky at 12,000 feet. Blakesley throttled back to efficient cruise speed, watching fuel gauges and engine instruments. The bombers they were to escort, 316 B-17s heading for a ball-bearing factory in Erkner just outside Berlin, formed up over East Anglia and set course for Germany. The Mustangs tucked into escort positions, weaving gently above and to the sides of the bomber stream. At this stage of the flight, fuel management was critical. The drop tanks fed first, burning down the external fuel before switching to internal tanks. This sequence was deliberate. If combat erupted while still carrying drop tanks, pilots could jettison them immediately, shedding weight and drag to restore the aircraft's fighting performance. They crossed into German airspace at 27,000 feet, still throttled back to cruise settings, nursing every gallon. The bomber stream stretched for miles, a sky train of heavy bombers leaving contrails in the palms. Cold air. Around 11:40, near Brunswick, the first Luftwaffe fighters appeared. Messerschmitt Bf 109Gs and Focke-Wulf 190, as diving from above, the classic bounce from altitude that German pilots had perfected over years of combat. Normally, this was where escorts would already be gone, turned back by empty tanks. But today, the Mustangs were still there, and German pilots hesitated. Years of habit told them American fighters shouldn't be this far east. That hesitation cost them. The Mustangs broke formation and engaged, turning inside the German fighters, using superior speed at altitude to dictate engagement terms. Captain Don Gentile shot down 2 Bf 109s within 3 minutes, exploiting the Mustang's climb rate to get above his opponents and use gravity-assisted dives. The laminar flow wings that North Americans' engineers had obsessed over let the Mustang maintain control at speeds where other fighters started buffeting and shaking. German pilots found themselves in the unfamiliar position of being outrun and outclimbed simultaneously. The furball scattered across 50 miles of German sky, but the critical fact remained. The bombers kept flying toward Berlin, and Mustangs kept protecting them. At 12:15, the formation crossed into Berlin's airspace. Flak batteries opened up, filling the sky with black bursts of exploding shells. But the weather worked in the Allies' favor. Cloud cover was so thick the anti-aircraft gunners were firing blind. The B-17s dropped their bombs through clouds using radar guidance and turned for home. The Mustang pilots checked fuel gauges. They'd burned through the drop tanks and were into internal fuel, but the math still worked. The return leg would be flown at optimal cruise speed, no unnecessary maneuvering, straight lines home. Weather and communication problems limited the effectiveness of this first Berlin mission. Only 32 bombers reached the target due to navigation, difficulties in the clouds. But the significance was unmistakable. American single-engine fighters had reached Berlin, engaged in combat, and returned to England. By 1430, the formation was back over the North Sea. By 1500 hours, wheels were touching down at English airfields. Mission statistics told part of the story. 5 bombers lost, mostly to flak. American fighters claimed 13 German aircraft destroyed. Actual Mustang losses were 5, with 3 pilots rescued. But the real victory wasn't the kill ratio, it was the psychological impact. 2 days later, March 6th, the Americans returned. This time, approximately 660 bombers attacked Berlin in daylight, escorted by over 150 P-51 Mustangs, along with P-38 Lightning and P-47 Thunderbolt groups. The escort fighters engaged Luftwaffe interceptors over the German capital and accompanied the bombers home. This wasn't a fluke or one-time penetration. The Americans had solved the escort fighter problem. At Luftwaffe fighter bases across Germany, pilots gathered in operations rooms, studying mission reports with growing unease. The tactical situation they'd trained for, planned for, optimized their entire defensive doctrine around, had fundamentally changed. Oberst Johannes Steinhoff, commanding Jagdgeschwader 7-7, read after-action reports from his pilots with mounting frustration. His experienced fighter leaders reported that American escorts were engaging aggressively over Berlin, with no apparent fuel conservation behavior. They weren't flying at the limits of their range. They had reserves. This contradicted everything Luftwaffe intelligence believed about American fighter capabilities. General Major Adolf Galland, General der Jagdflieger, and one of Germany's most successful fighter aces with over 100 victories, had flown combat missions during this period, despite his administrative position. He encountered P-51 formations over Germany and immediately recognized the implications. His combat assessments, submitted through official channels, noted that the Mustang was superior to German fighters above 20,000 feet. It was faster than the Bf 109 at altitude and more maneuverable than the WW-190. With extended range provided by drop tanks, it could escort bombers throughout their mission profile. German fighters could no longer attack bomber formations unopposed after Allied escorts turned back. Every intercept now required fighting through the fighter screen. Loss rates were climbing steadily. In January 1944, the Luftwaffe lost approximately 90 fighters, while claiming approximately 150 Allied aircraft destroyed. By February, German losses had increased to approximately 160 aircraft against approximately 230 Allied losses. March brought the Berlin missions and loss rates accelerated. The trend was clear and unsustainable. The Americans and British could replace losses faster than Germany could inflict them. More critically, they were killing experienced German pilots faster than replacement pilots could be trained. The Luftwaffe's pilot training program, once rigorous and thorough, had been compressed by necessity. Pre-war training gave pilots 300 hours of flight time before operational assignment. By 1943, this had been reduced to 200 hours. By spring 1944, replacement pilots arrived at operational squadrons with perhaps 150 hours total flight time and as little as 30 hours in their assigned fighter type. Meanwhile, American pilots completing training received over 300 hours before deployment, and their combat replacements often had additional advanced training. The experience gap was widening at exactly the wrong time. The summer of 1944 brought the full impact of American escort fighter capability. The 8th Air Force conducted deep penetration raids almost daily when weather permitted. Mustangs provided continuous escort from England to targets across Germany and back. Luftwaffe fighter losses mounted catastrophically. In June 1944, approximately 350-day fighters were lost, defending the Reich. In July, losses exceeded 350 single-engine fighters in the West alone, representing a 31.2% monthly attrition rate. August saw similar losses, with a 36% attrition rate. At these loss rates, experienced pilots were being killed faster than they could be replaced. Galland submitted repeated assessments to Göring and senior Wehrmacht leadership throughout this period. His September 1944 report stated the situation bluntly. The Luftwaffe could not win the air war. Germany lacked the resources, the fuel, the aircraft, and the trained pilots necessary to contest Allied air superiority. The Americans could replace losses faster than Germany could inflict them. Their industrial capacity was beyond Germany's ability to counter through combat operations. The only viable strategy was to husband remaining resources for defense of critical targets and hope for political settlement before complete collapse. The paper drop tanks continued to fall across Germany throughout late 1944 and into 1945. German civilians learned to recognize the distinctive cylindrical shapes lying in fields and forests. Initial reports sometimes described them as unexploded bombs, causing local panic until military authorities identified them as harmless fuel tanks. Instructions were distributed through civil defense organizations, explaining that the silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons. The psychological impact was noted in civilian morale reports. The sight of enemy aircraft overhead in such numbers that their contrails crisscrossed the sky, casually discarding expendable fuel tanks, reinforced the message that the Allies had resources to waste, while Germany scraped for every litre of fuel and every kilogram of aluminum. Technical intelligence continued analyzing captured American equipment throughout 1944, but focus shifted from understanding capabilities to documenting the scale of industrial disparity. Could Germany manufacture similar paper drop tanks? The technical answer was yes. The German chemical industry could produce suitable resins. German paper mills could manufacture kraft paper. The manufacturing process wasn't particularly sophisticated, but the practical answer was no. Germany's chemical industry was already operating at maximum capacity, producing synthetic rubber, explosives, and other critical materials. Resin production for non-essential items couldn't be prioritized. The paper industry was fully committed to military requirements for maps, documents, and packaging. Most critically, there was no operational requirement for extended-range drop tanks. By late 1944, fuel shortages were grounding large portions of the Luftwaffe. Pilot training was reduced to minimal levels. Operational sorties were limited by fuel availability rather than aircraft availability. Building drop tanks to extend range was meaningless when there was barely enough fuel for local defensive operations. The irony was stark and bitter to German planners. The Americans had solved the fighter range problem with paper fuel tanks at exactly the time when German fighters were grounded by fuel shortages. Different problems, different industrial bases, different outcomes. The Americans had more of everything: more aircraft, more fuel, more pilots, more aluminum, more industrial capacity, and sufficient excess capacity to optimize solutions like paper drop tanks. Germany was fighting a war of scarcity against an enemy for whom scarcity wasn't a constraint. By January 1945, the war's outcome was beyond doubt. Soviet forces were approaching the Oder River, less than 50 miles from Berlin. Western Allied forces had recovered from the Ardennes offensive and were pushing toward the Rhine. The Luftwaffe could mount only sporadic resistance, limited by fuel availability and pilot losses. The systematic study of American equipment continued at Reich, but it had become an academic exercise. The findings were documented for the historical record, but they could no longer influence the war's outcome. The final comprehensive analysis of the P-51 and its drop tanks was prepared in late January 1945. The report documented every technical aspect of the Mustang's range capability, the drop tank construction methods and materials, production estimates, and operational implications. The conclusion was unambiguous. The P-51 Mustang, equipped with expendable paper drop tanks manufactured from non-strategic materials, has rendered the German heartland indefensible against American daylight bombing. Germany lacks the industrial capacity to match American fighter production, the fuel to sustain combat operations at the required scale, and the trained pilots to replace losses at current attrition rates. The report was filed in Reich Air Ministry archives in late January 1945. Whether senior leadership read it is unknown. By then, technical reports analyzing American capabilities were simply confirming what battlefield reality had already demonstrated. The Luftwaffe, which had dominated European skies in 1940, was reduced to occasional desperate sorties by early 1945, hoarding precious fuel for missions that couldn't change the strategic situation. American fighters roamed freely over Germany, attacking targets of opportunity, escorting bombers, establishing complete air supremacy. Each paper drop tank falling from American aircraft was a reminder of the industrial disparity that had decided the air war. The war ended in May 1945. The systematic bombing campaign, enabled by long-range fighter escorts, including the P-51 Mustang, had contributed significantly to Germany's defeat. Industrial production had been disrupted. Transportation networks were devastated. Fuel supplies were exhausted. The Luftwaffe was reduced to a token force. These outcomes resulted from many factors operating over several years, but the ability to escort bombers throughout their missions over Germany, made possible by fighters like the P-51 carrying drop tanks, including those made from paper, was among the decisive elements. Post-war interrogations of Luftwaffe personnel consistently returned to a common theme. When asked when they first understood that Germany would lose the war, many technical staff and senior officers cited early spring 1944 as the turning point. The arrival of long-range fighter escorts over Berlin marked a decisive shift in strategic balance. Hermann Göring, interrogated after the war, acknowledged that long-range fighters had delivered a major strategic blow to German defensive planning and were among the most decisive factors in the ultimate outcome of the air war. His post-war statements consistently acknowledged that Allied air superiority, made possible by long-range escort fighters, had been decisive in Germany's defeat. The technical lessons learned by German engineers who examined captured P-51's and their drop tanks contributed to post-war aviation development. Many of these engineers immigrated to the United States or worked with Allied technical intelligence services after the war. Their detailed understanding of American production methods and design philosophy influenced their later work. The emphasis on standardization, interchangeability of parts, and design for manufacturability became standard practice in post-war aircraft development. The paper drop tank itself became a case study in wartime industrial innovation, taught in engineering schools and military staff colleges as an example of how resource optimization and mass production could provide strategic advantage. The lesson was clear and remains relevant today. In industrial warfare between modern nations, production capacity becomes as important as battlefield prowess. The side that can build more, faster, and more efficiently holds advantages that tactical and operational excellence cannot fully compensate for. This principle, learned at great cost by Germany in World War II, influenced military planning throughout the Cold War and continues to inform strategic thinking in the 21st century. The P-51 Mustang continued in service with various air forces for decades after World War II. The aircraft saw extensive combat in the Korean War, serving primarily in ground attack and close air support roles. The excellent range and endurance that had made it an outstanding escort fighter in Europe proved equally valuable in the very different operating environment of Korea. P-51s remained in frontline service with some air forces into the early 1980s, testament to the soundness of the basic design. More than 15,000 Mustangs were produced during and immediately after the war, making it one of the most numerous American fighters of the era. Today, over 100 P-51s remain airworthy, maintained by collectors and museums worldwide. The sight of a Mustang in flight, often still wearing the distinctive markings of wartime units, serves as a reminder of the aircraft's role in establishing Allied air supremacy over Europe. The broader historical significance of the P-51 and its paper-drop tanks extends beyond their tactical and operational impact. They represent a case study in industrial warfare and the importance of production capacity in modern conflict. World War II was decided not primarily on battlefields, but in factories. The side that could produce more weapons, more ammunition, more aircraft, more vehicles, and more supplies faster than they were consumed in combat held a decisive advantage. The United States achieved industrial mobilization on a scale unprecedented in history. Peak wartime production in 1943 to 1944 saw American factories producing aircraft at rates exceeding 50,000 per year, ships at rates of multiple vessels per day, and ammunition in quantities measured in billions of rounds. This industrial output supported not only American forces but also supplied substantial quantities of equipment to Britain, the Soviet Union, and other Allied nations through Lend-Lease. Germany, despite possessing significant industrial capacity and technical expertise, could not match Allied production. The reasons were multiple: smaller industrial base, strategic bombing of production facilities, loss of access to raw materials as territory was lost, diversion of resources to competing priorities, and inefficiencies in organization and planning. But perhaps most fundamentally, Germany was fighting a coalition whose combined industrial capacity was several times larger than its own. The paper-drop tanks falling across Germany in 1944 to 1945 symbolized this industrial reality in a form so simple and so stark that its message couldn't be misunderstood. The examination of captured American equipment by German technical intelligence services had been systematic and professional throughout the war. Facilities like Rechlin maintained detailed records of performance testing, material analysis, and technical assessments. These documents, many of which survived the war in various archives, provide valuable historical insight into how each side viewed the other's capabilities. German assessments of American equipment were generally accurate in technical terms. They correctly identified strengths and weaknesses of American aircraft, vehicles, and weapons. Where German analysis failed was not in understanding individual items, but in comprehending the scale of American production and the implications of that scale for the war's outcome. A single P-51 Mustang was a very good fighter aircraft. 10,000 P-51 Mustangs represented air superiority that no tactical skill or technical innovation could overcome. The story of German engineers examining paper-drop tanks at Rechlin in March 1944 is ultimately a story about the nature of industrial warfare. It demonstrates that in conflicts between industrialized nations, production capacity becomes as important as battlefield prowess. The side that can build more, faster, and more efficiently holds advantages that tactical and operational excellence cannot fully compensate for. This lesson, learned at great cost by Germany in World War II, influenced military planning throughout the Cold War and continues to inform strategic thinking today. The March 1944 missions to Berlin, the first to be escorted all the way by single-engine fighters, marked a decisive turning point in the air war over Europe. From that point forward, No target in Germany was beyond the reach of American bombers with fighter escort. The systematic bombing campaign could proceed with losses that, while still significant, were sustainable. German war production came under increasing pressure. Synthetic fuel plants, ball-bearing factories, aircraft production facilities, and transportation networks all became targets that could be attacked repeatedly with fighter escort throughout the mission. The cumulative effect of this campaign, combined with Soviet advances from the east and Allied advances from the west and south, brought about Germany's defeat 14 months after the first P-51's reached Berlin. The ability to sustain production of advanced weapons systems, to maintain supply chains under stress, to train the personnel faster than they're lost in combat, and to outproduce an opponent over extended periods remains as critical now as it was in 1944. The paper drop tank, simple in concept and humble in materials, represents one of history's clearest examples of how industrial capacity translates into military advantage. German engineers who examined those tanks in March 1944 understood immediately what they signified. They were not analyzing a superior weapon. The paper drop tank wasn't advanced technology. It was deliberately simplified using non-critical materials. But that very simplicity carried a message more devastating than any technical sophistication could have conveyed. The Allies had such overwhelming industrial capacity that they could afford to optimize designs for mass production rather than performance. They could manufacture fuel tanks from paper because they had unlimited paper, unlimited resin, unlimited manufacturing capacity, and unlimited fuel to put in the tanks. The optimization wasn't driven by scarcity but by efficiency. Germany's experienced engineers understood immediately what this meant. They weren't fighting an enemy desperately improvising with substitute materials. They were fighting an enemy so wealthy in resources that substitution was a choice made for efficiency, not a necessity imposed by shortage. That realization, crystallized in the examination of laminated paper cylinders recovered from German fields, marked the moment when technical understanding caught up with strategic reality. The war would continue for 14 more months, but the outcome was no longer in doubt. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.